and talking on mechanism of fluid flow and their significance. Introduction. Fluid flow is one of the most fundamental concepts in chemical, mechanical, and biological systems. Fluids, which include liquid and gas, exhibit unique flow that are influenced by factors like pressure, viscosity, and temperatures. Scientists must understand the mechanism behind fluid motion to design and optimize systems like water supply network and even biological systems such as blood flow in arteries. This topic will explore the various mechanisms that govern how fluid flow, the mathematical models used to describe them, and the practical significance in various real-life applications. Fluid mechanism is divided into two. There's the fluid statics and fluid dynamics. Fluid statics is fluid at rest, while fluid dynamics is fluid in motion. And there are some key parameters that we should take note while going on, which is pressure, velocity, density, viscosity. It's denoted as P. This one is V, and rho. Then and pressure is the force exerted per unit area. Velocity is speed and direction of fluid movement. Density is mass per unit volume, and viscosity is a measure of fluid's resistance to flow. These properties influence how fluids behave under different forces and constraints. Example of fluid flow, the importance of fluid flow mechanics is in water treatment. Understanding fluid property helps in designing pumps to move water efficiently without excessive energy consumption. Property of fluid. The first one is viscosity. Is divided into the high viscosity and low viscosity. Example of high viscosity is honey, and low viscosity is water. Density. I'm talking about the properties of fluid. So density, surface tension, compressibility. Then flow type, we have the laminar, transitional, and turbulent. Laminar is smooth and orderly. Transitional is between the laminar and the turbulent, while turbulent is chaotic and eddy filled. Laminar flow, it occurs at low velocity with parallel streamlines and minimal mixing. Characteristics is the Reynolds number is less than 2000, and the flow is predictable. And there is an equation. Where this change in P is the pressure drop, this R is the pipe radius, this mu is the viscosity, and this small r is the radial position. Then the turbulent flow. Turbulent flow is unpredictable with fluctuations and swirl. The characteristic is that the Reynolds number is greater than 4000. It's higher energy loss due to friction. An example of this type of flow, which is turbulent flow, is blood flow in arteries under stress, and airflow and model, and requires experimental validation. Then we have compressible and incompressible flow. Compressible flows are gas flow, changes in density and pressure. Incompressible one is liquid flow and its density is constant. Example of incompressible is water flow system. An example of compressible is jet engine, shock waves. And the compressible, which is gas, has an equation. The gas, which is PV, is equal to nRT. Then another type of fluid is another kind of fluid is Newtonian and non-Newtonian fluid. Newtonian fluid is constant viscosity, e.g. water and air. And this is where the shear stress is linearly proportional to shear rate. While non-Newtonian fluid is the viscosity changes with shear rate. Then there's the pseudoplastic and there's the dilatant. Example of pseudoplastic is the blood, paint. Dilatant is cornstarch in water, and they are used in designing mixer, pumps, and pharmaceutical formulation. Then Reynolds number and flow classification. Application of Reynolds, we have classifies flow regime, helps choose pipe sizes, pump capacity. An example of Reynolds are flow in IV tubes, flow in fire tubes. There's also the Bernoulli's principle and application. It is used for the conservation of energy in fluid flow, and the equation for the Bernoulli's principle is P plus 1 over 2 rho V square plus rho G H is equal to constant, and it is applied in aircraft wings and sprayers. That is to pressure difference atomizes fluid. That's spray. Then in conclusion, understanding fluid flow mechanism helps engineers and scientists model, predict, and optimize systems in fields ranging from aerospace to healthcare, whether designing a jet engine, building an irrigation system, or analyzing blood flow. The principles of fluid dynamics are universally significant, with a firm grasp on flow types, governing equations, and measurement techniques we can enhance safety, efficiency, and innovation in countless applications. Thank you.
Hello, thank you very much. Please, let's clap for her. All right. All these things you have been saying, they are correct. In fact, I so much love Bernoulli's principle. They are, in fact, you are grounded in these things. But the topic that you have not really touched the topic as what the topic says. It says mechanism of fluid flow and their significance. I I expect these things you are saying are part of the topic, but I wanted to cement it, relate it to what the topic says. It says making of fluid flow. You can just use one paragraph or maybe some few sentences to talk about statement to talk about makings of fluid. How does fluid flow? What mechanism? You know, I'm talking to you already because you have up to 2 minutes to go. If not, I would have stopped you. But how does fluid flow? That's the question. And then what is the implication? What is the significance? Especially now in pharmacy.
Yeah.
That's what the topic is talking about. What you are saying is true, but it's not actually the topic you talked about. I will score you for what is that is but I'm not that comfortable because you have not actually touched the topic.
Okay, concerning how it affects pharmacy,
How does fluid flow? What makes it? What's the meaning of the fluid? How does fluid flow? What happens when fluid flow? How does fluid flow? That's the question.
Yes.
What mechanism of fluid flow, and what is the significance?
So
you have 1 minute.
I'll start with the importance of fluid flow.
Feel free.
The first one is that it's in drug manufacturing process, because many pharmaceutical operations involve the movement of liquids such as solutions, emulsions, suspensions, and processes like mixing, filtration, crystallization, and extraction depend on efficient fluid flow for optimal results. The second one is tablet and capsule production. During tablet and capsule manufacturing, coating solutions and binding agents must flow properly to ensure uniform drug delivery and quality. The third one is sterile drug production or preparation, that's aseptic processing. Fluid dynamics is essential in laminar airflow system used in clean rooms to prevent contaminations during sterile product preparation. The fourth one is infusion and injection system, like IV drips, syringes, and infusion pumps rely on controlled fluid flow to deliver drug accurately into the bloodstreams. The fifth one is drug delivery systems. In biotechnology, no, drug delivery system, that's inhalers, nasal sprays, and topical application. They all depend on precise fluid flow to ensure correct dosage and effective absorption. Then formulation stability. Proper mixing and flow prevents separation of emulsion or suspension, improving the shelf life and effectiveness of pharmaceutical products. Then transport
Your
across
time is up.
membrane.
Your time is up. Thank you very much.
Thank
Please,
you.
let's clap for her. Thank you very much. Thank you very much. God bless you. Stay. Have you not seen? You lost mark now because you didn't hit the point. You should have start from look at it. Please, if you are in presentation, look at the topic. You may have a wonderful what you are saying may be true. But once it has no link with the topic, it has a link, but it's just like having scattered this point. You not now you not cement it and link it up to the topic.
Yes, sir.
Yeah, it's not at the end of it because I mentioned it now because of 1 minute remaining. You not started talking about significance in pharmacy. She mentioned up to 5 points. All this while she has been talking about Dolores principle, Dolores density, and left with very important thing. Anyway, please let's clap for her. Thank you very much. God bless.
Yes, sir.
Thank you very much.